We're an open source project, 100%. We live under the umbrella of the Apache Software Foundation. So that means at least two things. We care a lot about our community. So we build a very diverse contributor and user base. And two, we have a very clear licensing policy. Everything is licensed under the Apache software license version 2.0, which means that in the future you can safely build on this on these kind of applications or frameworks, because you know you'll not get any surprises from a licensing point of view. Those things have happened, or from a community point of view. And the next thing, as a sort of a personal note on Apache Sling, I think we prefer to be more explicit rather than magical. I see a tendency recently of falling in love with annotations, for instance, and I think I know where that comes from. It comes from all of us who are lucky enough, let's say, to have worked with EJB's version 2 something, where an EJB was a huge XML descriptor, and then we discovered annotations. So that obviously eliminated a lot of boilerplate, a lot of unnecessary code, but I think at some point annotation overload is something we should avoid. So we try to keep things more concrete and down to earth rather than magical. From a history point of view, we're a relatively old or mature project. So we were, in the mid-2000s, this project was initiated at Day Software, now part of Adobe. And in 2007, we entered incubation in the Apache Software Foundation. After about 1.5 years, we graduated. So that meant we were supposed to understand what being an Apache project means from a community and a legal point of view. And now in 2015, we had release number 8 of our main product. I hope we'll get release 9 out this year. From a evolution point of view, now, yeah, I realize the details maybe are not that visible from here. So this is an analysis on the code repository that we have. So this is 2008, this is 2016. So we have a very increasing code base size. This one is code, the light blue is code, the almost black one is comments, the green one is blanks. So we have a steady evolution in our code base. Now, this is per language analysis. We have 87% in Java, and the rest, we have 9% Maven XML build files. No, I'm kidding, it's not just Maven XML build files. We have lots of other stuff like Kara features and Eclipse plugin descriptors. But we do build with Maven. Sometimes we have too many POM files. This is our activity summary. So you see a mostly increasing trend. And this is our contributor summary. So overall, it's still increasing. You might notice a sharp drop here. It's where this data stopped being analyzed rather than us having stopped working, which hasn't happened. Okay, so now that you understood basically what Apache Sling, sort of this application framework that wants to be Superman, let's talk a bit about content-driven and RESTful applications. So, sorry, when I try to think about content-driven applications, I find it hard to give a very generic definition. So what I do is try to gather examples. So one example that I found is an application where you can post short messages up to 140 characters. Nobody knows why now. Initially it was for SMS. And you can have other people subscribe to your messages. You probably know this one. Another one is this sort of networking application where you post messages or images or videos for all your connections to see, and then if your friends or family don't like what you posted, you get angry with them. You probably know this one too. Now there's something which is a bit more developer-oriented, which is somewhere where you push your code, you have issues, milestones, downloads. Oh, no, this one. Okay. And the examples can go on, right? A microblogging site, page for building communities where you vote, upvote, and downvote. So it seems that a lot of the internet is content-driven. I try to do the other way around, right? Pick up the other side of the coin. How do I find some applications or websites which are not content-driven? So basically, these are the good examples that I think I found which are not content-driven. If you want to build an HTTP proxy, sort of like a poor man's VPN, right? You want to hide your origin when accessing a web page. That doesn't sound very content-driven to me. If you want to build a Bitcoin miner, that's sort of a cryptocurrency. If not familiar with it, it's based on calculating a mathematical proof to produce a new unit of currency. Again, not very content-driven. Foreign exchange, stock exchange trading. So looking at all these, my opinion is that if you don't own the data, or if you're not very close to the data, it means that you're not content-driven. So conversely, the rule of the thumb is that if you own the data that you expose to your application, you're a content-driven application, and you should structure your approach accordingly. So obviously, all applications consist of data and code. Content-driven applications aren't different from that as well. But what's different for content-driven applications is that I always try to put my data first. There's a tendency for us to, rather than finding a solution, a technology for our problem, we tend to find a problem for our technology. I'm sorry, did I say microservices? No, I didn't mean that. So again, we try to define our problem very clearly, and in case of data-driven applications, the data is at the core of our application, and that's what we want to start with first. So when I mentioned in the beginning that Apache Sling is RESTful. Now, I meant the other kind of RESTful, not the one in the hammock, but the one as in REST, representational state transfer, which is commonly known as JSON over HTTP, which is not a very fair description, but that's another talk. And REST talks about resources. Resources are basically things which can be named, things which can be addressed. I'm Robert. I'm a resource. Probably project managers see me that way. We have 5 resources in that room, 5-man months, project is done in 1 year. Good job, everyone, let's go home. Resources have properties, right? I have static properties like my date of birth, but my age is a dynamic property. So resources are defined as basically key value properties, glorified hash maps. Resources can optionally have children, and unlike in the real world, resources can have at most 1 parent. So where do you find this resource model in your everyday work? This is probably familiar to you. It's the first line of an HTTP request. First the verb or the method, then the whole path, and then the protocol. So what we see here is a resource being addressed. So that's the full path to the resource. That's the resource name, release-8, and then we recompose the whole path by simply listing the parents. And if you think that a URL is basically a universal resource locator, you begin to understand why resources and URLs are so tightly linked. So how would resources look? Well, we definitely say they have a path, so post hello world.html, and then we start adding some metadata. If it's a blog post, it probably has a title, it has a body. It has a date when it has been published. But then someone else has authored it. And this is where things start to get interesting, because I say here the author is user's admin. I say that the author is a resource. And if I think that resources are addressable, and that resources are unique in the repository, I realize that I don't need any identifiers. I don't need to say here author is ID number 12. I don't need to generate unique identifiers or a UUID or something like that, right? I can use a resource reference to say this is who my author is. I can say all my comments are located under this path. All the post images are located under this path. That buys me a lot of transparency. So, of course, a user can be an administrator. These are just some technical data, but you can add lots of profile information for that user as well. So you can have a full display name, group memberships, whatever you want. It's just a resource representation. Images are resources. And to make a short sidestep here, whenever I get to this point, I get reminded of a visual metaphor that I often saw in cartoons at my age. So whenever a character has a moral dilemma, a little devil pops on his shoulder and says, you gotta do the bad thing. And then a little angel pops on his other shoulders and tries to convince him to steer the right way. At this point, I think some of you are getting a little devil on your shoulder who says, but you can't properly store assets in a relational database, right? Either use vendor-specific extensions or you sacrifice performance and scalability. We don't have the right tools to do that. And I'm going to try and be the little angel and tell you, okay, this is doing technology over defining the problem that we have to solve. This is a solvable problem, but let's try to get the design first properly. Assets. You have the location. You notably have a media type. You have to know how to serve a certain file, whether it's a JPEG or a GIF or a PDF file. You have the contents. You can have a name. That's the most trivial example. On the other hand, if you're doing a blog post, let's say, or a image sharing site like Imager, you want to store your pre-compiled thumbnails somewhere. You don't want to regenerate those all the time on the fly. So you can have those renditions already written in the repository. Did anyone here use Subversion? Okay, not so many. Yeah, it was the thing that was cool before Git was cool. And before that, CVS was cool. And before that, USB sticks were cool. Now, Subversion also has a very similar mechanism with properties per object, but I'm not going to go into that then. Okay, so we have these resources. Now, obviously, we want to serve these resources to our users, because otherwise, they're completely useless. So, I've seen two major classes of mapping your resources to an actual request. I call the first one controller-driven because it puts the controller at the center of serving the content. And this is something I see pretty often in Java web application development frameworks. The annotations are fictional, but I hope I'm not that bad at annotation design, and it's clear that it serves GET requests for users /something.html. The advantage with this kind of approach is that it's very obvious. Once you look into a controller, you immediately see what kind of request is this going to serve. The disadvantage, on the other hand, is that you don't get a clear overview of what, if you get think up of a request, is this going to be served by my application, yes or no? Is there a controller for it? Do I get a 404? You're not sure what's going to happen. The second variant of the first class is something I see in Rails mapping files, probably other frameworks as well, is that you have a global definition file, and you simply list all your mappings for your application. So in this case, it's a shorthand for take the user's controller and map all requests for it to /user. You can sort of get post requests, head requests, whatever you want. With different variations, take the articles controller and serve under news, take the images controller and serve under get as well. That's obviously the other way around, right? You have a global overview, you know what happens to requests incoming to your application. You don't necessarily know from your controller what happens. But both of these variants of the controller-driven approach, suffer from the fact that you don't necessarily own or model the whole URL space of your application. And what do I mean by that is imagine a Christmas tree. Right, so I think this Christmas tree is a good representation of your application. So up there at the top where the star is, I hope you can see it, is basically the root of your application, application space, so www.example.com/, right? That slash is right there at the top. And then as you go down, you have various branches of your application. And what you would do is say, hey, here at the top, I have my welcome controller, right? That's the slash. And here, I think /users would do just fine. And /articles would do here as well. So as you can see, you're basically pinning decorations in your Christmas tree where your URL is, with the downside that you have a hard, as your application evolves, and if it's a non-trivial application, it will evolve. And as you get many controllers, you'll get problems with ensuring consistency in naming, in hierarchies, in access control at least. So my thought experiment is, what if instead of a Christmas tree, we had a bonsai? Now, are you at least familiar with the bonsai? Not really. It's this sort of miniature tree that the art of raising a bonsai is modeling how you want it to grow. So instead of a predefined Christmas tree that you decorate, consider a bonsai that you control. You decide what branches, you decide if you want to snip this branch, you decide if you want another branch to grow. Still a bit fuzzy, I know. Okay, the contrast is good. So what that means is that we build beforehand a resource-driven approach. So instead of building controllers, we design our resource tree. So we view our resources in a hierarchical fashion. So at the top, I hope you can see a slash, and you can see the structure of our application, / content news, and then Sling Launchpad 8, and then other articles and assets. That is, of course, very close to what you would see on a website. But that happens also to be, from my point of view, an ideal way of structuring your website content. So if we could achieve this kind of resource view or organization, then there would be no intermediate step of mapping our content to URLs, because the URLs are already there. So if I go to /, I get the resource. If I go to content HTML, I know exactly which resource gets served. So that's an intermediate step I have eliminated, and makes it extremely easy to view my resources and reason about how they are named, organized, and how access control is set up for them. And some of you might be wondering, okay, but I had a welcome controller, an article controller, users controller, whatever, and they did specific things, right? So what you're proposing now is that everything is served the same. And the answer to that question is that each resource has a sort of a discriminator property. Each resource has a property which identifies which category it belongs to. So if I go to the root, it says link : redirect. So I know that's going to be a redirect to some other page. If I go to Sling ID tooling, it says my /site /article. So I know that is an article page. And that's how the underlying system is able to differentiate between serving different resources. Okay, so we've seen the overall principle. The question is, what can Sling do for me? What is it actually good for? So I've talked a lot about this content-driven part and how we shouldn't put technology before choices. Now it's time to talk about technology. So Apache Sling uses something called JCR, the Content Repository API for Java. It's a Java API. It's designed in a couple of JSRs, which is built specifically for content-oriented applications. And at the time when it was designed, it tried to marry both, let's say, traditional and more innovative approaches in persistence. So we try to look at databases and say, hey, we have some things we like there. People like free text querying, SQL, and maybe other models. They like referential integrity. They like transactions. So let's do that. But on the other hand, we pretty much liked some things about file systems. So file systems naturally form a hierarchy, which is good. You can transparently store files in a file system, right? Well, that's what a file system does. You can do access control on folders, and then it applies hierarchically down to the rest of your folder structure. So we try to bring those things to JCR as well. And then we added some more goodies. You have full text querying, you have built-in versioning for your persistence engine, you have something called observation, which is basically in-process triggers for your Java application. If something happens in your repository, in your database, let's call it, then you will get an immediate notification in your Java application. Yes, and even across a cluster. The implementation we use right now is Apache Jackrabbit Oak. It's, I think, the 4th major iteration. It's a continuation of Apache Jackrabbit, which was the initial project, and then Jackrabbit Oak was built from the ground up to be more performant and scalable. We use OSGI. How many of you have had some experience with OSGI? Okay. So we use OSGI basically as a module system for application. It allows us to be very, as I mentioned, to be very modular. OSGI, in our opinion, has the advantage of being very dynamic. So when an application is assembled, it's not the end of the story. Your application can be reassembled at runtime many times. So that has benefits for both development and production time. Also, it has a very powerful service layer where your components are composed and recomposed. And that has worked very well for us. It has lots of add-ons. Some of them are listed here. And more importantly, since microservices has taken the world by storm, it forces applications to handle real-world dynamics. And what does that mean? Usually when you structure a Java web application using a dependency injection framework, you assume the wirings are final. So once you get a reference to a data source, that data source is here to stay. Now, since everyone discovered microservices, they realized that this is no longer true. You have a reference to a microservice which may be down for the next 5 minutes. And then your application needs to be resilient and handle that. That's something that many applications weren't ready for. And it's one of the pains in adopting microservices, but on the other hand, it's something which makes your applications more resilient. Now, OSGI dynamics force you to do that anyway. Since components may activate or deactivate at runtime at any point, then your code is explicitly forced to know what happens, or it's not explicitly forced necessarily. Your code must be ready to be stopped, right? If you have a component which relies on component A, which relies on component B, component A might be deactivated at any time. And that can cascade throughout your application. And if you handle this gracefully, you have a very, very solid application. And the fact is that in real life, things would happen anyway. Your data source might be flaky. It happens. One of your components might be misconfigured. And so you would have needed to handle those faults at runtime anyway. But now OSGI makes them explicit. So JCR is our main repository. That's what handles, in a typical Sling application, perhaps 95% use just this JCR persistence layer. Now, we also have the repository abstraction is pluggable, so we have production level MongoDB, Couchbase, and file system. You would typically use these when you would either have some data in another system and you think it's easier to extract from there, or maybe you have some advanced querying capabilities that you want to use MongoDB or Couchbase for, and you're not ready to move them to JCR. Authentication is pluggable as well. Sling works as a front end, so you do have various mechanisms of extracting authentication credentials, forms OAuth, basic HTTP, and then it delegates to Oak. Oak, being a repository, can have its own user database, or it can delegate to some other external data source. LDAP is the most often encountered one, maybe Active Directory. Templating engines, we support a number of that's a hard word, templating engines. That one you probably don't know. It's something called HTL. It's a very imaginative product name. It comes from HTML template language. It's something which has been purposefully built for Apache Sling, and I'll show it in a demo a bit later. We have support for Flimeleaf, JSPs, Groovy, FreeMarker, Velocity as well. And then lots of other features. I'm not going to go through each of them. I'd rather, okay. So for developers, we understand it's very important for a developer to be productive at development time, and not only to have a nice set of features. So we have a set of Maven plugins, which help with assembling Sling applications, running Sling containers, stopping Sling containers. Also IDE plugins for Eclipse, IntelliJ. And the aim of these plugins is to make it very fast to get changes from your local IDE onto the Sling server. Now, okay, I tried to be a bit funny. I'm not sure if it is going to be extremely funny when talking about deployment options. So the first one, we have 3 main deployment options. The first one and the most classical one is a jar. Okay. So the Sling application is a jar file, and you execute java-jar, and everything, you launch the main Sling application, everything expands. The GSR repository is there, the OSGI configurations are there, everything. Now, java-jar can be a bit hard to type and to remember. Some people are more familiar with containers, right? So you can also use Docker. Docker start is easier than java-jar, okay? And the third one is the classical application. If you still prefer running in a classical web application, you can do a war, right? A war file. Okay, it wasn't that funny, but anyway, still I tried. So these are the deployment options. And if we're doing more operations-oriented stuff, that's a classical Sling deployment topology. You have an HTTP front end. It can be the Apache web server. It can be something else. And then since Sling and Oak are both Java applications, they run in the same process. And we use a persistent called segment-based persistence. It's a fancy name. I'm not very familiar with the details, but it's file-based persistence. It's append only, tar files, memory mapped, very, very fast. It's a very performance standalone option. Now, the only thing that you, let's say, sacrifice is high availability, because it only offers a cold standby option. So if you're unhappy with cold standby and you want something which is, has more availability, you probably want a distributed setup, which is based on something we call document-based persistence. Again, Sling and Oak are together in the same instance. You can have however many instances you want. And they connect to MongoDB, which is one of the leading document-oriented persistence engines. And here, of course, you can have whatever MongoDB setup you want for high availability. So at the cost of some performance, not too much, but there is a performance hit to using MongoDB in this setup. And of course, some operational complexity and cost. You can have a high availability deployment setup with Sling. Again, from an operations point of view, we have a web console which comes from the OSGI web framework. Some examples here, you have a list of bundles or modules running in your system together with their state. It's a very good, this is the first entry when you want to know what do you have running on your instance and if something went wrong. Here you see an example of being able to configure or reconfigure components at runtime. Since OSGI is dynamic, you can easily do that. So you would, in the background, you have a listing of your configurable components and an example form for reconfiguring one of them. And something we contribute additionally is a console for reconfiguring your loggers which I find it very useful, either at runtime or dev time or production time. So you can add custom appenders, you can set custom logging levels, additivity, anything. It's based on logback. And something which is very useful from a support point of view is what is called a status page. It's a plain text dump of the state of one service, and you can view it as it is, or download it as a zip file, or download the whole diagnostics for the whole system as a zip file. And extremely useful for those times when you do remote support or you need to troubleshoot a remote situation for a customer and you don't have a remote access or administrative access to get that information. And it's much easier to request a download of the whole state of the instance and then being able to analyze it offline or away from that instance. Okay, so that pretty much wraps up the talking part. I'm going to take you through a couple of steps in a sample Sling application. So let's see which one is this. Okay, let's do it a bit smaller, I think. Right, so this is an application I'm very proud of, especially this image. I spend most of the time on this image and this text. Anyway, as you can see, it's a pretty simple blog. It has a couple of articles. There's read more links. Something I want to point out from the start is that we managed to get this unordered list, ordered list split properly into HTML. So no mismatched tags here. That's a sign that the templating engine that we use is HTML aware. It understands what it processes and doesn't mingle it. Now, if I go to an article, there's no surprise here. A bunch more text, some comments, some funny faces. I find out that people love it when I add funny faces. So let's see what funny face I get. Okay, so I had a comment, another funny face. So that's basically the whole application. If I want to look a bit at how, if I want to look at how the application is structured, is this, this is, I guess, readable. We assemble the application using something called a launchpad. I was prepared for a different resolution. Okay, I'm not sure what I did here. Let me try and reopen. Okay, so we have a plain text listing of all artifacts that get into the final launchpad. First thing I want to point out is that we can reuse other launchpads. So if you have a base setup where you define, let's say, your company's 80 or 100 or whatever specific modules, you can inherit that. There's also support for removing. And then you list all sorts of bundles, which are jars with OSGI metadata that you want to get into your application. You can also set default values for configurations. So you have, you want to deploy your application with a default data source configuration, you can do that. And if you can have this, what we call a repo initialization, in which you basically create some default empty structures and set up ACLs and create users if you want to. So it's related to the security setup. Now in Sling, we also have a default way of rendering resources as JSON. So if I want to access, using this resource-centric approach, my content blog posts JSON output, I just fire off an HTTP request, and then I get the, let's say, raw, unfiltered information about that resource. This comes in very convenient when building rich applications or single-page applications, because you know that for every resource you have a consistent representation in JSON format. If I go to posts, it's the same. If I go to comments, it's the same. Now, sometimes I want to get a more deeper representation. I don't just want one level. So I can use something which is called a selector. So I can, okay. So if I append .1, I ask Sling to give me resources one level deep. So of course I can go 2, 3, or however many levels deep I want. Of course, if you want to override this behavior, we'll see a bit later how you can override it and add a custom servlet. And I think, okay, that should be enough. So this is one of the one custom servlet example. We have a special annotation says this is a Sling servlet. Works for a specific resource type, and it generates zip files. And apart from setting the content type, which is pretty standard stuff, I get a zip output stream, and because I'm doing this resource-centric approach, the request already knows my resource. I don't have to go to the database, find it for a certain ID, pass request parameters. I just do request get resource. And then I iterate over its children. Again, no need to look them up in the database because they're already ordered in such a structure. And the rest is pretty boilerplate code. I generate a zip entry and then the contents for it. Now, if I go to back to the front page and instead of posts.html, I do posts.zip. No. It means I didn't deploy it. Good. That will be it for the next demo. Now, something else I wanted to show you is about our rendering, our templating engine. So if I go to this comments HTML, which is the actual template snippet used to render a comment, I can see that it's very HTML-like. Actually, it's HTML5 plus some data attributes and some expression language. Again, as in the servlet, the resource is the resource that is being handled by the request, and I can access its properties using a value map. Something to note here is that I have this comment.js, which is a JavaScript server-side helper. So to make using view logic simpler, we have a concept of Java or JavaScript helpers which live near the model, and they are for special purpose just for use inside a template. In here we do something simple like returning a formatted date. And if I go back to the page, I can see that the XSS protection that I hinted a bit about earlier. So if I output an HTML by default, if I output an HTML snippet by default, it's escaped. I can of course ask Sling to not escape it if I really know what I want to do, but by default Sling protects me. We're running pretty much out of time, so this is a list of resources. First one is the Apache Sling project, the Apache Jackrabbit Oak project, which powers the persistence. I have a couple of more slides related to OSGI, Sling, Jackrabbit Oak, if you're interested in that. And you can reach me on Twitter at that handle. Okay, I hope we have time for a couple of questions. If anyone has them at the moment, if not, I'll be available after the talk as well to talk. And I have a little form set up. I'm not sure if the organizers have one set up. I didn't get one in time. So if you want to leave an impression about this talk or start a conversation about anything, feel free to use that as well. Thank you.